So this article deals with electrolyte testing. The idea that these researchers had, or someone in their hospital had, was that children were being tested too much. Their electrolyte testing was going to an extreme that was making higher costs for the hospital, and also potentially raising the children's risk of false positive diagnoses that might mean they might have to be treated for something that they really didn't need to be treated for. So that's why they wanted to investigate. They weren't really investigating which ones were over-testing so much as how can we reduce the overall rate. So there's some ethical considerations too here, and I think the nurses even pushed back a little bit because it's not a clear black and white. We want to, like, of course we always want to reduce cancer risk, we always want to do certain things. Here they picked something that their outcome variable, it would be actually really bad if they took this all the way to 0. So it's a little more complicated type of thing to study, outcome variable to study. But nevertheless, let's take a look at what they did here. So when we go to the first control chart here, you'll notice a couple differences. The main difference you'll see is this red line, this control lines, control limits are not at all straight. So what's happening there? That's because the thing that we're measuring here is basically a unit rate for each I guess it would be each week here. So the number of possible patients or 10 patient day units that they have in each of these weeks is varying, which means that the control limits are going to vary. Essentially, the higher the sample size, so the higher the number it is, the more accurate the limits can be. So if you find any place where it's really tight, like right here, it's pretty tight, and you go down and look, these sample sizes will be higher. If you find lower sample sizes and look up, you'll see like a big wide control limits. So the more they had, the more accurate they could set the control limits for that particular week. And this varied idea of measuring a rate that varies is a U chart. A little bit different than the ones we were looking at earlier. In that it's not a normal distribution, it's a Poisson distribution, but that really doesn't affect you in terms of interpreting the results. It would impact how you set up these limits. You'd have to look up that formula and use that instead of just plus or minus 3 standard deviations. But interpreting it is fairly similar to what we had looked at before. So they set up a really nice, healthy baseline. It looks like they have about 18 months worth of data here, where they weren't doing any specific interventions. They were just seeing how many of these electrolyte draws are we doing, and they measured it per 10 patient days. That way it doesn't vary just based on, if they just did the number of draws per week, that could vary pretty severely based on the number of patients that they had. So this is a way of kind of doing a percentage or a rate, so that it accounts for that population change. So we set up this nice baseline, and then what they're hoping happens, the researchers at least are hoping, they want to see fewer of these draws being done. So they would like to see this average line drop. So how do they approach that, and what do we see going on here? Well, indeed, when they start the interventions about right here, we do see a drop. Now, it's easy for us to see the drop in retrospect. How would they have seen the drop if they were conducting the actual study? Well, if you think about it, if they had continued this average line all the way across, this red line would have been here. The control limits would have continued to go up and down a little bit, but one of them would have been up here. The upper limit would have been here. The lower limit would have been down here. And what we would have seen right away is that we have some special cause variation, because if you picture this red line going out, continuing, we would have 1, 2, 3, 4, 5, 6, 7, 8. I mean, it wouldn't be long at all until we had 8 in a row that were on the same side of that average line. And that would have been an immediate flag that you could say the process is out of control. A more accurate way to say it here would be that we have some kind of special cause variation, specifically that we have significantly lower laboratory draws going on. So this was probably a success for the doctors involved in this study. You would have also known that wherever this lower control limit is, you would have seen these points go out of control because they would have been lower than these lower control limits. And if we look over here, we see some of these points out of control also, right? So this would have certainly alerted us to the fact that something's going on, and in this case, it looks like the overall average was lowered. But what about this point, or this point, or these points? These are also out of control during the baseline period, and that's not ideal. Typically, as you're drawing your baseline, you want to, part of the idea of doing a baseline is that your process should be in control at that point. If your process is out of control, especially with, I mean, several points being out of control here, and they may be failing some of the other tests also, it makes you question whether this process is really stable enough, or whether it's really following this Poisson distribution, or whether there's other factors going on here, like maybe a change in administration, a change in the staff, something like that. So all of that throws a little bit of doubt on the reliability here. Nevertheless, if you did continue to plot this based on the mean and the other statistics here of this distribution, you would certainly have indication that the process was, that there was some special cause variation. Now, one thing I notice as I look at this, so they had all of these interventions here. If I just look at this chunk along here, it almost looks like this process is going back to where it was before. It almost looks like there were these interventions that people for a few months here were intentionally not doing these electrolyte draws, that they knew that administrators or perhaps doctors were watching over them, and so they decreased it. But then over time, as things relaxed, it started to creep back up to normal. So even though they draw this red line here based on the entire average after the intervention, so if you did a t-test, I'm fairly sure that would be a significant difference between before and after. One of the advantages of the control chart is you not only see all the points, but you see how they fit in terms of time of when they take place. And that really does give us a benefit here of seeing that it appears that these are creeping back up. And again, there were some thoughts on some resistance among nurses who felt that certain draws were not the best way to handle the situation. So what I would want to do if I were at this hospital, or if I were actually concerned about this process, they talk about saving all this money, I would want to continue monitoring. And my hunch is, if you continue with these new control limits, if this trend would really be a legitimate upwards trend coming back to this original levels, we would soon start seeing the process go out of control. We'd see it breaking through this upper control limit, or maybe more than 8 or more in a row above this red line. So I'm kind of curious what happened beyond this, or maybe if they even cut it short intentionally, maybe knowing that happened. But I'm being a little suspicious there. Overall, though, that chart is fairly similar to the other charts that we've analyzed this week. Okay, here we have more that conventional straight limits, and here I still have that same suspicion where it looks like there was this drop early on and then perhaps rising up. If you look, well, that point, let's say that point is right on the line. If that point is right on the line, we have 1, 2, 3, 4. We would ignore that. 5, 6, 7, 8, 9, 10. 10 points in a row on the upper side of the line. So 10 points in a row on either side is going to throw a red flag. 10 points in a row above the line would suggest that the actual mean is not right here, but at this point it might be higher than that. Now we do have some lower ones that hit near the end also, which is why it's hard to say. I would like to continue to see some data on that. But this would be a similar type of chart that we saw up there. Okay, and one final chart I want to look at here is called a P chart. This is in that same study. Here again we have those variable control limits, and that's coming from the variable sample sizes that are taken on these weekly averages here. And actually I shouldn't say average, I should say proportion. The reason they're called a P-chart is because they are proportion. So when we talk proportion, we're talking a yes-no question. It could be died or not died. It could be took the medicine, didn't take the medicine, had a fall, did not have a fall. Anything that's a yes-no type of variable, what we measure is the proportion that are yeses, and as we monitor that over time, we would do that with a P-chart. So here again we can see that we have a baseline established, although again, as that baseline was being established, there were several instances where the data was out of control, which makes it a little less reliable of a baseline. And then here, if you would extend that baseline out, you would have caught at least 8 points in a row that were below that. This one genuinely does look like it's decreasing over time. We don't see that initial decrease followed by a steady increase. So in terms of renal panel draws, it does look like there was a decreasing portion of renal panel draws after the intervention started. Okay, and zipping down to the conclusions, they cleanly summarize by saying they did reduce the rates of electrolyte testing, 35% in the actual charges. I think they put a dollar figure to it, which was a fairly substantial dollar amount, which I'm sure would attract certain parties at that hospital or on the board. It does mention here that these reductions were achieved without increasing adverse effects. This is a claim that I'm not sure if they covered it in the article. I may have overlooked it. This is one that I would want to hone in on, because here's the type of thing you could say if, let's say, this decreased testing did lead to more incidences of something happening with the children, but maybe the p-value was 0.08 or something that wasn't statistically significant. And I think they did mention that they had used some kind of control chart. So I'd really like to see that control chart also, just especially because I know that it feels like their intention is to definitely decrease the rate of electrolyte testing. So they would probably want to shrug off any adverse effects, because those are going to prevent them from making these cost savings. So that's the type of data, if I was investigating this, I would want to pay close attention and to see if it was really no sign at all of increasing adverse effects.